You're listening to Quantum Revolution with Karen Curry Parker, exploring new frontiers in consciousness, science, and evolution. Join us in intimate conversations with cutting-edge scientists, spiritual leaders, artists, disruptors, and visionaries who are working towards reframing the narrative of our future by healing the rift between spirituality and science, reclaiming creativity, and laying the foundation for a new world. And now, here's your host, Karen Curry Parker.
Is there life out there? This is the question astrophysicists have been exploring for decades. In late 2017, scientists at a Hawaiian observatory glimpsed an object soaring through our inner solar system, moving so quickly that it could only have come from another star. Avi Loeb, Harvard's top astronomer, showed that it was not an asteroid. It was moving too fast along a strange orbit and left no trail of gas or debris in its wake. There was only one conceivable explanation. The object was a piece of advanced technology created by a distant alien civilization. In today's conversation, we're exploring the question, is there life out there, with Dr. Loeb, who is the Frank B. Baird Jr. Professor of Science at Harvard University, Chair of Harvard's Department of Astronomy, Founding Director of Harvard's Black Hole Initiative, and Director of the Institute for Theory and Computation within the Harvard-Smithsonian Center for Astrophysics. In Dr. Loeb's new book, Extraterrestrial: The First Signs of Intelligent Life Beyond Earth, we learn about Oumuamua, the first known interstellar object detected passing through the solar system. But this book isn't really about Oumuamua. It's a story about why curiosity is essential to science and how curiosity gets squelched when the scientific process is influenced by the pressure for research dollars. It's also a story about the challenge of shifting paradigms and how our first response, both in the scientific community and in the world at large, is not to wonder and be amazed by new information, but to push new information away and to resist data, especially if the data itself defies what we think we know. Hi, welcome to Quantum Revolution. I'm Karen Curry Parker, and I'm here today with a special guest, Dr. Avi Loeb, who is a physicist or an astrophysicist who teaches at Harvard and who has written a book about extraterrestrial life, which is kind of a hot topic and certainly a topic that probably has gotten you a lot of press and questions. And you started sort of contemplating extraterrestrial life in response to a phenomenon that occurred in 2017 when a telescope in Hawaii picked up an unusual asteroid that you have decided or proclaimed or explored the possibility that this asteroid, because it defied so many traditional metrics of asteroids, maybe wasn't actually an asteroid, but was from another place of another time, the beginning of little green men arriving. Talk to me about what is Oumuamua, which is the name of this extraterrestrial phenomenon.
So that was the first object that we discovered from outside the solar system near Earth. It was found by a telescope in Hawaii in October 2017. We knew that it came from outside the solar system because it moved too fast to be gravitationally bound to the sun. At first, astronomers thought, it must be a comet, because comets arrive to us from the outskirts of the solar system, and that's the place where they could be easily dislodged into interstellar space. So if you imagine an object coming from another star, it would most likely be a comet. Unfortunately, it didn't look like a comet. Usually comets have gas or dust surrounding them. That's the cometary tail. That is a result of the sun warming up the ice on the surface of the rock of the comet. And there was no such gas or dust around Oumuamua. In fact, the Spitzer Space Telescope looked very deeply and put very tight limits on any carbon-based molecules. So not only that we couldn't see it, as we usually do in the case of comets, in fact, we didn't even detect traces of these cometary molecules. So it was definitely not a comet of the type that we have seen. And then people said, okay, well, maybe it's just rock without any ice on it. Maybe it's an asteroid. The problem with that is, as the object was tumbling every 8 hours, the amount of sunlight that was reflected from it changed by a factor of 10. And that meant that the object has a very extreme shape. Just imagine a piece of paper tumbling in the wind, and the area of the paper that you see in front of you changes by a factor of 10. In fact, the best fit to the variation of light was that of a flat object, pancake-like, not cigar-shaped. Then, even more strangely, the object exhibited an excess push away from the sun, and the only way I could explain it is that it's a result of reflection of sunlight. Because there was no evaporation from the object, you couldn't get the rocket effect. In order for that to be effective, the object had to be very thin and less than a millimeter thick. And nature doesn't make such things like a sail. So I suggested maybe it's artificial in origin. And then
Okay, so I have to stop you right there.
Yeah.
Who did you suggest this to, and what did they say? 'Cause that's
Yeah. So I, at first, of course, it went through stages. I didn't have an agenda. I'm just like a kid. For me, science is a continuation of my childhood curiosity. And I felt just like the kid who looks at the emperor and says the emperor has no clothes. And everyone says, no, the emperor is dressed. This object is an asteroid. This object is a comet. I say, no, it doesn't look like it. I just state the facts that seem obvious. So I wrote a couple of Scientific American articles where I expressed the suggestion that it may be artificial in origin. And then I wrote a scientific paper with a postdoc that just arrived to my group, to my research group named Shmuel Bialy, where we actually explicitly said that it might be an artificial thin object. And the paper was accepted for publication within a few days. We didn't have any press release, but then a couple of bloggers reported about it, and it became viral. I was supposed to go for a conference in Berlin, the Falling Walls, and I took the flight. Just before I left my home, there was a television crew that arrived to the front door, and I said, I have to leave right now. Sorry, I cannot give you an interview. But they said, okay, just answer the question. Are we alone? And then I arrived to Germany and I was able to open my email. There was no Wi-Fi on the flight. And there I saw Good Morning America and various other programs asking me to appear. And when I arrived to dinner in Berlin, I didn't know anyone. It was a conference. I was the only astronomer in this conference, and there were people from many different disciplines. So I came to dinner. I didn't know anyone. And I sat at the table and everyone said, we know who you are because we saw you in the news. And then I didn't have a minute to myself there because, there were so many reporters that wanted to speak with me that they put them together in a room. And then I remember like a room full of reporters and one of them shouting from the back, some Italian reporter shouting, do you think that you are Galileo? In the sense that,
that didn't end well.
Anyway, so the bottom line is there was a huge amount of interest. And I ended up also writing my book, Extraterrestrial, that was published in January this year. And once again, there was a media storm around it. It became bestseller, was translated to 25 languages. There were about 30 filmmakers and producers that approached me. I had about 1,300 interviews over the past 7 months, which was only possible because of the pandemic. I could do back-to-back interviews from home without leaving my home office. So I did it all over the world. And by now, I met so many people outside academia. It's really fascinating to witness how small of a bubble is the academic world. There is so much beyond it outside in society. But at any event, the real question, it's not so much that the public cares about it. At the same time, the scientific community was ridiculing this discussion and saying, no, it must be a natural object, period. And, there were negative statements on social media. I'm not subscribed to social media. I don't care how many likes I have on Twitter. But scientists, colleagues made negative comments. I think, it really doesn't matter what scientists say. What matters is what this object is. It's just like in the case of Galileo Galilei. Philosophers said, no, we know that the sun moves around the earth. We don't want to look through your telescope. And today they would have canceled Galileo on social media. But who cares? The earth continued to move around the sun. We see it when we launch a spacecraft. The spacecraft sees the earth moving around the sun. Who cares that these philosophers put Galileo in house arrest? That didn't really change the course of the earth around the sun. It only maintained their ignorance. And if people just attack me personally or ignore the anomalies of Oumuamua, it would not make Oumuamua a rock. If it's not a rock, it doesn't matter that on Twitter, people just produce a lot of excitement on alternative ideas that it may be a rock. So just to give you an example, there was a paper in the scientific literature saying, no, it must be natural, period. And then a few months later, another team said, well, in order for it to be natural, it needs to be a chunk of frozen hydrogen, something that we've never seen before. And the problem with that is that hydrogen evaporates very quickly, so it doesn't really explain. It won't survive the journey through interstellar space. Then a few months later, there was another paper saying, oh, it may be a cloud of dust particles, very porous, 100 times less dense than air. The problem with that is that it will not maintain its integrity when it gets close to the sun. It will get heated by hundreds of degrees. Then a few months later, there was another team claiming, oh, maybe it is a nitrogen iceberg that was chipped off the surface of a planet like Pluto. And there the problem is there is not enough nitrogen in the Milky Way galaxy to make enough objects. And so my point is, if it was obvious to people that it's natural from the let-go, why did you need these iterations of people coming up with different explanations? And each of these explanations invokes something that we've never seen before. So to me, it resembles a situation where you have a caveman presented with a cell phone, and the caveman says, I'm used to playing with rocks. So the cell phone is a rock of a type that I've never seen before. Just like these astronomers were saying, Oumuamua is a rock of a type that we've never seen before, a hydrogen iceberg, a nitrogen iceberg, dust bunny, whatever. And then, of course, it could be the beginning of a learning experience if the caveman is open-minded. But on the other hand, if the caveman throws the rock away and says, oh, it's just a new rock and I don't care about it, like many scientists say, then that will be the end of it. But if the caveman presses a button on this unusual rock and it realizes that it records his voice, and then presses another button and it records his image, then the caveman would recognize that it's not really a rock. So my point is, let's get more evidence. Let's not assume that we know the answer in advance. Science is a learning experience. We should be modest, just like kids. That's the way kids learn about the world. The problem is adults pretend very often to know much more than they actually know. And I remember that from being a kid, sitting at dinner and asking difficult questions. And then the adults in the room would pretend that they know much more. And that would be the good situation. The bad situation would be when the adults in the room would dismiss the question and say, that's irrelevant. We don't care about it, just because they didn't know the answer. And unfortunately, I thought that going to science would be actually very uplifting because I would be surrounded by people that are like-minded, that are willing to explore new questions, learn about the world without prejudice. But what I'm finding is that this experience from childhood repeats itself. I'm surrounded by people that either dismiss the question or pretend that they know much more than they actually know.
So your story isn't a new story. It's, I think, a story that we see being played out in multiple arenas right now, in the face of evidence around global warming, in the face of how we combat viruses. And, we are seeing a very interesting challenge in how do we explore the world through the lens of science. And I think what you bring up for me personally, and I think probably for many of our listeners, is what's going on in the scientific community that people who have decided that they are going to be professionally curious are backing away when they hit phenomenon or insights or data that doesn't fit into the box that they are conditioned by. Why is this happening?
Yeah, so I was asked many times this question over the past 7 months and after my book appeared, and it took me a long time to figure out the answer. And if I had to summarize it with one word, I would say ego. It boils down to the fact that when you establish a scientific career, you want to be regarded as the world expert. You want to maintain an image that you know everything about your field of expertise, so that when something unusual shows up, you don't want to admit that you missed something fundamental. And you would be very jealous if someone else recognizes something that you have missed. So because of that, and both of these issues relate to your ego in a way, because on the one hand, you want to pretend that you know everything, that You want to maintain an image that will garner awards and a place in honorary societies, and so that you are the world expert and the leader in that field. And at the same time, you don't want someone else to scoop you, to find something, that you missed in exactly the field where you are supposed to be the expert. The point is, even if you think that you know everything, every now and then nature brings something that you haven't anticipated. That's my point. We should be humble. We should be modest because it's a learning experience. Nobody forecasted quantum mechanics a century ago. It was a complete surprise. Albert Einstein had a problem with interpreting it, and he was wrong. People that are traditional, that think about what we knew already and are confronted with something new, make mistakes. Albert Einstein made a mistake about arguing that quantum mechanics has spooky action at a distance, couldn't have that. So he was wrong. The point is, you learn by nature giving you new clues. But if you are closing yourself off, then you will never learn something new. It reminds me of a colleague of mine when we left an auditorium where a lecture was given about Oumuamua. He said to me, Oumuamua is so weird, I wish it never existed. And to me, that is completely contradictory to the definition of a real scientist, where you're supposed to welcome surprising results, anomalies, something unusual, because it's an opportunity for you to learn something new. You should say, Oumuamua is so weird. This is exciting. Let's get more evidence about objects like it. At last, there is something new in my field of expertise where we can, discover perhaps objects of a new type. If it's a hydrogen iceberg, nitrogen iceberg, or artificial, I don't care, me personally, because we will learn something new. We've never imagined that nitrogen icebergs or hydrogen icebergs will be generated at large quantities and we would see them nearby. So even if that happens to be the case, we learn something new, something fundamental about the nurseries that make these objects. If we learn that it's artificial in origin, that would be remarkable. That would change the future of humanity. So I think it's an opportunity to learn something new. It should be exciting. That person should have been very much in favor of getting more evidence, but instead it bothers that person. Why? Because that person wants to be the expert in this field, wants to pretend that everything is already known, and it bothers him that Oumuamua is so weird. Okay, so that is the fundamental issue. And then, of course, in the specific context of extraterrestrial life, there is this tendency of scientists to shy away from the public's interest because you have science fiction, you have a lot of reports about unidentified objects, and scientists want to distance themselves from those claims. And, it reminds me of what happened 1,000 years ago when a lot of people argued that the human body has a soul. So now imagine if scientists would say, oh, there are all these crazy claims that the human body has a soul, and therefore anatomy should be forbidden because it will damage the soul of a person if you dissect the body of a person. So imagine if scientists were to say, this is a controversial subject. We don't want to deal with it. We don't want to do any operations on the human body because there are all these crazy claims that it will damage the soul and anatomy should be forbidden. Where would modern medicine be? Science should address any topic that comes along to which the scientific method can apply because it promotes a better sense of reality. So if you understand the human body, you can actually repair it. You can improve the health of people. We use that on a daily basis to help people right now. In much the same way, if we understand that we are not the smartest kid on the cosmic block, it would help us plan our acts in the future to have the appropriate aspirations in space, to get a better perspective about our relative intelligence, so to speak. Overall, I think it's always good to have a realistic assessment of the environment you live in, rather than say, no, we know the answer. Either, we know that the sun moves around the earth in the days of Galileo, or, you have to show me extraordinary evidence before I'll be willing to discuss that there is an extraterrestrial intelligence out there.
I appreciate what you're saying so deeply because I think in many of the interviews we do here, we talk to people who are consciously harvesting, building a body of data around extraordinary phenomenon that potentially could change our paradigm and increase the quality of well-being in the world. Our intention in these conversations is to never say, oh, science, let's go to Roswell and let's get our data from, standing in the desert. Not that there might not be something there too. I mean, who knows, right? But what I think you're really speaking to is what I would consider, and I think certainly in the conversations we've had on quantum revolutions, is a crisis in science and a crisis in how we know. And certainly you say ego, and I understand that there is an element of that as well. And I also just want to pull out, without, again, inflaming things too much, to talk about what about funding for scientific research and what role does that play in how we interpret data?
That's an excellent question, because what happens right now, the federal agencies such as NASA, the National Science Foundation, the Department of Energy, that support physics and science more broadly, they make their decisions based on committees that select the people who are awarded grants. And they are usually populated, these committees, by mainstream scientists that basically bring in the same prejudice that you find within the scientific community. So very often, because funds are scarce, you end up with conservative choices and not as much innovation as one should allow. And my point is, you always want to support ideas that may not necessarily be successful, because you never know which path to take. And you want to support, maybe at a 20% level, innovative ideas that are not yet clear whether they would deliver what they promise. And that is done a lot in venture capitalism or in the commercial sector, where the big companies allow some blue sky research that does not yet have immediate applications. It should definitely apply also to science. And it's really surprising to me that you find as much or even more innovation in the private sector than in the academic world. It should have been the other way around. The second thing is that now we have a lot of wealth in the private sector. And most of my research over the past decade was supported by the private sector, because it's much more open-minded. It's not populated by these committees that I was talking about. So, for example, in the context of the search for extraterrestrial equipment near Earth, in July 2021, just a few months ago, there were a number of multi-billionaires that came to the porch of my home, and they had questions about my book, Extraterrestrial, and they were inspired by the vision, and they decided to contribute funds to my research. And within a couple of weeks, I had $2 million that allowed me to establish a new project that I called the Galileo Project, where we would search for objects like Oumuamua and try to get more evidence about their nature, and also try to understand those unidentified aerial phenomena that were included in the report of the Director of National Intelligence to Congress on the 25th of June this year, 2021. And so altogether, I now have 80 scientists engaged in this project, the Galileo Project, where we are just buying now the instruments that we want to use, and we will start building the first telescope system in the coming weeks. And that is very exciting. And it shows the power of the private sector in funding initiatives of this type. It's sort of like what happened during Renaissance, where artists were supported by very wealthy individuals rather than the dogmatic religious institutions. So this, I think, is a very promising path, the private sector, for supporting innovation. And I wish that the federal support would have followed a similar path, where innovation would be rewarded. Very often what you find is those granting agencies asking you to tell them in advance what you are expecting to discover. And that's contradictory to the nature of discovery. You cannot really forecast that in advance.
I love that. And I think I just want to, again, throw down a little bit of an asterisk here just for our listeners to say that just because you're reading a scientific study that has been funded by the government doesn't necessarily mean it's wrong. I think that's an important distinction to make. And also remembering that if we're going to engage in our scientific exploration that is a continuation of our childhood curiosity and our natural state of wonder, that we also have to not predetermine what the outcome is before we explore. So I think that's crucial. So One of the things we like to do on this program is to take some time at the end of our conversation to just ask our guests, if you could imagine the future, what would you imagine? And in your case in particular, I would really love to hear from you, your imagination or your dream about what you think the future of scientific research would look like.
I'm very encouraged by the development in artificial intelligence. We have self driving cars right now, and AI systems will, in the future, outsmart us. And my hope is that artificial intelligence will eventually analyze data, scientific data, and make discoveries in science. At that point, of course, human scientists will not be needed, but an AI system would offer a great advantage because it may not be so connected to its ego the way humans are. So my hope is that an AI system that would look at an object like Oumuamua and realize that it doesn't match the qualities of a comet or an asteroid will have no problem admitting that and saying this is something else rather than looking around and checking how many likes such a view would get on Twitter or pretending that it knows much more than it actually knows and all these human faults. So my hope is that science will progress much faster at that point. Also because AI systems can digest a much larger data volume than humans can. They would look at all the information we have and be able to immediately connect the dots, so to speak. I very much hope and look forward to the time when AI systems will do science instead of my colleagues. At that point, of course, tenure in academia will not be needed because you don't want to give a computer tenure because the hardware can survive for a very long time, much more than a century. So I do think of AI systems. A lot of people that develop AI systems are really anxious, worried that they will go out of control and they would do things that we don't approve. After raising two girls, I feel that it's very much like educating kids, that you can train them at an early phase and just hope for the best afterwards. You give them your set of values and then you hope that they would cope with the world according to those values. Now, of course, even with kids, you have situations where the kids go in strange ways that you haven't anticipated. But, that's the way things are. And I don't think we should be more anxious than parents are with kids. So these AI systems will be our technological kids. And aside from them doing science, they can also become astronauts. That's really a great advantage because humans are not designed to go into space for long periods of time. There are very harmful cosmic rays that damage the human body after a few years and can cause death. And we were selected by Darwinian evolution to survive on the surface of Earth. And if you make a system out of electronics and send it to space, it could survive millions or billions of years, and that would be the natural thing to do. And if this system is intelligent so that it's autonomous, it doesn't need any feedback from us, doesn't need any guidance, that's ideal because the distances between stars are so vast that it takes 4 years for light to travel the distance to the nearest star, and it takes tens of thousands of years to travel across the Milky Way galaxy. So you can't imagine sending a probe that will wait for guidance from us. It needs to be autonomous, and AI systems would be the perfect astronauts. They can survive the long journey and they would be autonomous. So this is really the future that I hope for. And since I can imagine this future for ourselves, I can also imagine that other civilizations already reached that point because they may have formed 1 billion years before us. And therefore, we should search for their AI systems, their equipment. And that's what the Galileo project is all about.
So you shared with us before we started that you're speaking next week on this topic with a theologian, which I think is a really beautiful pairing because certainly the idea that maybe we're not the darlings of the cosmos and that maybe there are others that have been ahead of us is a relatively humbling thought for humanity. I always throw this out for people, especially when they start getting afraid of AI and they think we're going to end up like the end of Space Odyssey 2001. What you see on Facebook is curated by algorithms, and your perspective on the world is already being influenced by not technically artificial intelligence, but it's at least a computer program that's bidding through data and choosing what you get to see on your Facebook feed. So you're already being impacted by it. And so why not look at how can we harvest and harness this technology to better suit our evolution and our growth?
By the way, I do not have any footprint on social media because I promised my wife when we got married that I will not subscribe to any of these outlets. So my views are not shaped by Facebook or Twitter or any of these outlets, gladly. I don't care how many likes I have, as I said. But with respect to religion, I should say that, many religious texts talk about the fact that humans were created in the image of God, and that there is this divine entity that created the universe and life inside of it. In our laboratories, we are already getting close to the point where we would produce synthetic life. And I recently wrote a Scientific American article just a week ago that argues that in the future, once we unify quantum mechanics and gravity, we might find a way to create a baby universe in the laboratory. If we do that, then, a very advanced scientific civilization may be a good approximation to God. So instead of saying humans were created in the image of God, you might actually say that this is the image of very advanced scientists. It's nothing else. So in fact, the culmination of science, the most advanced form of science, may be what we used to call God. So if we meet, for example, a very advanced civilization, for us, it may look like God if it can create life, if it can create baby universes. That's what we called God before. What I'm saying is there is usually the notion that science, advanced science, is a contradiction to religious notions. What I'm saying is the two might be the same.
Okay. Good thing you're not on social media. So I thank you so much for joining us here today. I got so many brilliant takeaways from you around your perspectives and your thoughts. And I'm just really, really in love, and will probably continue to share the idea that science is a continuation of childhood curiosity. I love that. That is so appropriate. Dr. Loeb, thank you so much for joining us here today. And again, your book is Extraterrestrial. It's very easy to find. You can get it on Amazon, Barnes & Noble, all over the place. And if you get the chance to connect with Dr. Loeb and hear him speak, do take that opportunity to continue to stretch your mind and let yourself contemplate possibilities, that there are answers that are extraordinary, that defy our paradigms and the way in which we understand the world right now, and that it is a really beautiful time to continue to explore what else is possible. So thank you for joining us.
Well, thank you for hosting me, and I hope that eventually there will be also an interstellar edition to my book.
Oh, I love it. I'm going to see if I can secure the rights. In the legal system in the United States, you are innocent until proven guilty. It seems to me that the scientific community might benefit from adopting a similar principle. Data is possible until proven otherwise. It's only natural that doubt and suspicion are built into the scientific system. The scientific method starts with a hypothesis that must be proven to be true or not. A healthy dose of doubt mixed with curiosity and wonder keeps science honest and as unbiased as possible, given the nature of the human mind to crave certainty as a weapon against fear. Proving a hypothesis to be valid or invalid requires impartial observation and the ability to duplicate a pattern of truth over and over again. Good science not only requires curiosity and a willingness to explore all possibilities, but also time. The system that we call science is competitive. The pressure to be first for the sake of credit, ego, and money often causes researchers to sew up conclusions in record time without the necessary curiosity and willingness to entertain new possibilities. New data has to stand the test of time and repetition. It also has to be measured against what we already know, with the willingness to entertain new possibilities with curiosity. A system that is run by money and the fear of losing funding perverts our interpretation of the data. It also causes a collective lack of trust in science, and increases the time it takes to implement new, innovative solutions in collective systems, such as the education or the healthcare system. When we liberate curiosity and knowledge from the pressure to be first or right in order to secure funding for more research, we increase the possibility that we will find the solutions to the challenges facing humanity today. Thank you for joining me for Quantum Revolution. Please be sure to subscribe to this podcast on your favorite platform so you don't miss any of the amazing shows we have in store for you. If you're curious about who you are and what you're here to do, please visit our website, www.quantumalignmentsystem.com, to learn more about your unique role in the cosmic plan.
Thank you for joining us on Quantum Revolution with Karen Curry Parker. We hope you found this conversation inspiring. For more information on how to change your world and to hear more about our guest today, visit quantumrevolutionpodcast.com. Make sure you follow us on your favorite podcasting platform so you don't miss a single episode of Quantum Revolution. We'll see you next time for some more groundbreaking conversations with Karen and her guests. How will you impact your world today?